Good evening. Thank you for attending. My name's Beth McLean. There are a lot of familiar faces here. We appreciate you coming out. I work for Dr. Victor Fishman, who's the head of the Washington office for the Applied Research Lab here at Penn State. The seminar this evening is being sponsored by the Office of Naval Research, ONR. You'll probably remember that from last week. They sponsored that seminar as well. Specifically, the individual we work with who assisted us with this is Dr. Anthony Jr. The speakers this evening are Dr. Tom Fu and Mr. Tim Klingensmith. And Dr. Fu is the head of the operations of the Hydromechanics department at Naval Surface Warfare Center, Carderock, and that's in West Bethesda, Maryland. And Mr. Klingensmith is with the Advanced Machinery Systems Integration branch, and that's also Naval Surface Warfare Center, Carderock, and he actually works in the Philadelphia office. So the first speaker this evening is Dr. Tom Fu. Dr. Fu.
Thanks, Beth.
Sure.
I don't actually remember. I mean, last time I gave this talk a year ago, 2 years ago, there was Beth sent out a little what it was about. I guess what we're really talking about is research and employment opportunities at Naval Surface Warfare Center, Carderock, both in West Bethesda and in Philadelphia. So I guess the question is, you know, in the flyer that was sent out a couple years ago, it said summer 2011 and beyond, what will you be doing, or what will you be doing this summer? So that is a question. What are you guys thinking about for this summer, and what will you be doing next? I kind of made it more general. I do think it is, you need to start thinking about what do you want to be doing this summer, not just what will you be doing. And, you know, if you're looking for a job or an internship, you really have to start thinking about what do you want from a job. I interview a lot of people. One of the things I ask them all the time is, what is your dream job? And surprisingly, a lot of people can't actually answer what their dream job is. Or you get an answer like my son, which is like lay around and watch TV or play video games, but nobody pays you to do that, or not very many. The other question is, these things aren't really just a job. You guys didn't go to Penn State to get a job and just earn money. You really want a career, and what are you going to do over the entirety of your career? And then it comes back to, what do you really want from your career? What are you looking for to get out of it, not just what do you want to be doing? Which really comes back to, what do you want out of life? And it's kind of a big deal. You don't really think about it when you're your age. I never thought about it. I just wanted, you know, to get through the next day or the next week or through the homework assignment. But you kind of think about it as you get older, because part of it, you work at some place for 20 years, and you kind of go, what have I done? You kind of think of, you know, it's 2,000 hours a year or more, and you go through the same gate, you know, 360 times a year, you know, it piles up. So you want to say, what is it? I'll concede, I don't know why you should listen to me. It is something you should think about. You should think about, should you be listening to your teachers, your professors, your friends, your parents? Don't tell them I didn't tell them to listen to your parents, but you really have to start thinking about it. And so why should you listen to me? I am the Director of Operations for the Hydromechanics Department and the Director of Science and Technology, which means nothing to you and actually almost means nothing to me. I do teach at University of Maryland. I teach a graduate course in hydromechanics and undergraduate ship design course when I get a chance. I was the head of resistance and propulsion division. I was a group leader before that, doing specialized research. I was a research engineer before that when I first got to Carderock, and then I was a grad student at Hopkins and at Scripps out in San Diego, and then I was an undergraduate. And as an undergraduate, I worked in a hydro lab in a tow tank at Purdue University. So the one thing that's always been there since I was, you know, 19 years old and I got a job at the tow tank is I like fluids. I've done everything in my whole career based on liking fluids and breaking waves. That's kind of been the consistent thing. I haven't had any idea what I wanted to do with myself at 18. I don't have any idea what I want to do next. But everything is sort of focused on the things that I really liked doing, which was fluid mechanics and turbulence and breaking waves. I'm not even all that fond of ships and submarines. I just like fluids, but that's where it's led me. So as I've chased sort of the things I liked and things I was interested in, it sort of led through this, and that's what you kind of see. So it's worked for me. So summer 2012 and beyond, what will you be doing? This is my summer 2011. It's actually more complicated than my summer 2010. It started off, if you go through this, you know, way up here in the top, that's Scripps Pier out in San Diego. I went to graduate school there, and I still go out there and do experiments. So we did an experiment out there on the end of the pier. Then below, actually below that is La Spezia or Lirici, Italy, and on the northern coast of Italy. I went to a conference there. Then I went out to Stanford and met with a couple professors and watched my son graduate. Then I went to Norfolk for the NEAT conference, and then I went to Rotterdam also in June for another conference, and then into Alexandria for another conference on ship stability. So that gets us through June. Then the Coliseum was right at the end of June into July. That was actually my vacation. There was nothing I actually on purpose didn't work there. I go there occasionally to actually work with the tank there, but that was actual vacation. Then I came back and went to Annapolis and then to London. And then Penn State's in the middle. And then the bottom is Rio. I just got back from Rio 2 weeks ago for the ITTC conference. And then Purdue University and the other little one with the pink cherry blossoms, which I don't think I ever saw a pink cherry blossom at Purdue when I was there. And then I'll end the summer next week in the Netherlands, and then the week after that in Hawaii at another conference. So it's been a jam-packed summer of travel and doing experiments all around the world, and I never would have dreamt I would have been doing that. That's what it's become. And I think I've enjoyed every single one of those trips. So it does talk about what do you want from all those things and what do you really want from your life. And what I've seen is happiness, I guess. At this point, that's what I want out of my life. But what does that really mean? Enjoyment, to matter, to make a difference. To make a difference to who, though? To yourself, to your family and friends? Is that to your career, to society? What are you really chasing? And it's one of the things you have to think about as you choose. Now, totally different circumstance. Right now, you guys are going to graduate and say, I need a job more than anything. And that is a driver. But as you have to make choices and you get to choose what you want to do, you need to think about how does it all go together. So what did I want to do and what did I set out to do? Started off doing three-dimensional separated flows, not for submarines, but just on axisymmetric bodies. That's what I studied and what I did at Hopkins. And that led to the job at Carderock and doing RANS calculations, CFD. Basically because I was doing my experiments at Hopkins for my PhD work at Hopkins at the model basin down in Carderock, and that led to a job there. Led to a job there mainly, I think, because I was doing my experiment there, and I had my first son, and when you're 24 years old, 25 years old, and you're getting paid almost nothing as a graduate student, I think they took pity on me and hired me a day a week to supplement my income. And that's where I started. And so after I finished, I looked around, but I was already invested in the government at that point. And so I started doing computational work, and that led to the free surface work, and that led to other measurements, and that led to full-scale trials. So what you see is it's sort of, I just kind of chased it. What you see in this thing is the USS Cole, DDG 67, and you'll see it compared to model tests. And that's mainly what I spent my time doing technically, is looking at model scale and full-scale measurements on breaking waves and wakes and turbulence. That is the Cole about a month before it was headed over to the Middle East, and before it got blown up in the Middle East, or not fully blown up, but damaged. And that was also right before a tropical storm was coming, so you can see there's sort of chop on the water as the wind picked up. So you can see the difference between the model scale waves and the full scale waves from the ship. That's basically what I study, scale effects and braking and turbulence and wave braking. What that meant was chasing ways to measure it, so quantitative visualization methods, both at model and full scale, environmental sensing of the environment when we're out doing field tests, knowing what the environment's doing, vehicle dynamics, because what the ship does makes a difference, and that got into ship control and guidance. So what you see is this is the Athena. It's a 154-foot planing boat down in Hawaii. We spent probably 4 or 5 years, every year, every 18 months, going out on the ship making full-scale measurements of the full-scale breaking waves. It is the coolest thing in the world to be in charge of an experiment in the middle of the Gulf of Mexico in the middle of the summer, and because they were laser-based methods, it was all done at night, so it's, 75 degrees, it's a clear night sky, there's millions of stars out there, and you're out on a boat, and there's dolphins in the bow wave, and you're getting paid to hang out on a boat in the middle of Florida to make measurements. It's one of the amazing things about the kind of work you can do. What I do now, I'm the Director of Science and Technology for the Hydromechanics department. That means I have technical oversight over the department, the technical work it's being done. I help spend a lot of time developing engineers and scientists. I come and do a lot of talks like this. I was at Purdue last week. I'll be at Michigan in another month. I want to make Carderock a better place. That includes Philly. A better place to work, a better place to do work, manage the internal research funds, or help manage the internal research funds, and do a lot of university outreach. Why is that? How is that different? I still do a lot of my technical work. I do this because it's getting a bigger and bigger view of what Carderock does and what the Navy has to do. So what will you be doing? What do you want from a job? What do you want from your career? What do you want as a career, and what do you want from your life? So next summer, what will I be doing? Exactly what I want to be doing. Kind of the thing is that those are the jobs that I want. These are what I do. I probably will be out in San Diego again. I probably will be at Penn State again next summer. I typically go to Iowa. I didn't go to Iowa this summer. I have to be in Rio in June for the OMAE conference. That's the one that was in Rotterdam this past year. I will still be at Carderock unless things drastically change. This is Pasadena. Caltech's there. I've got a meeting set up for there, and then Gothenburg in the fall for the ONR symposium. We're all on my schedule already for next summer. So what will you be doing? That's really the question. So could spend your summer in Carderock in Washington, D.C. There it is. It's, you see the tow tank. Tow tank itself is 3,000 feet long on the one long tank, and then there's a 2,000-foot tank and a 1,000-foot tank inside of that. There's explosion test pond. There's maneuvering and seakeeping basin. My office is, kind of just to the right of that tower right there, right on top of the captain's office, actually. So Carderock, for those of you guys that have been there in D.C., it's right here on the Beltway on the west side, right on the river as you come down. So what does it mean? I just threw this together actually a couple weeks ago because I was trying to figure out how to get across what it means to work for the Navy. What do you get out of it? This is sort of a snapshot of the U.S. Navy. I went to a talk earlier in the spring by the CNO, and he kind of said this is what the Navy's got to do every single day, and it's kind of impressive. So back in the spring, if you remember, there are multiple things going on, and they're constantly going on, and it's a big responsibility for the Navy, and Carderock's part of that. So what you see is, you do see, hospital ships off of Japan. There were hospital ships off of Haiti. Well, actually, there's only two, one on each coast. Supporting that, there was a carrier battle group supporting Japan after the earthquake. There's submarines constantly out there. The one thing that I forget, and I work for the Navy, there's ballistic missile submarines out there in the ocean constantly all the time as part of that, and that's a big part of what the Navy does. It's a part that's sort of dropped off the map. During the Cold War, it was the biggest part of what the Navy did, but that's still there. And there's a big piece of the Navy that has to sustain that, even though it's not, Navy SEAL teams doing stuff. It's ballistic missile submarines out in the middle of the oceans, constantly on patrol, and the people and the efforts that go to support that. That's always there. Along with that, there's what's going on in the Middle East. So you look over here in the Persian Gulf and up in here, there's two carrier battle groups in this little chunk in this northern part of the Indian Ocean supporting war in the Middle East. There's carrier battle groups in the northern Atlantic. There's ones in the south. There's also the what's called the UNOLS fleet. It's the Navy Oceanography research team. There's Navy ships supporting universities for oceanographic research all over the oceans. And then there's obviously the SEAL teams. And they're in these various areas along with other areas. So it's a big job. There's a lot of ships out there. There's a lot of people supporting it. And what you're going to see is Philly's got to support that from the fleet maintenance and the maintaining the ship side. Carderock works on it from the ship design, submarine, and the in-service engineering parts. And it's all part of that, and it's what has to happen every day. Then there's also this little nuclear reactors thing, because there's a big chunk of the Navy that's tied to the nuclear reactors program and what they do. This is Carderock, another picture of it. You can see the tanks, you can see the maneuvering seakeeping basin back here. It's basically the size of a football field. It's 30 feet deep and 20 feet deep, two different sections. The water tunnel's over here. It's very much like the water tunnel across the street at ARL. What do? We provide people, facilities, and tools for research and development, testing and evaluation, acquisition support, in-service engineering, logistics, systems integration. We develop new technologies, and we support the maritime industry. It is all focused on the fleet of today, the fleet of tomorrow, and the Navy after next. That's what you have to remember. We're doing all aspects pretty much all the time. And it is a little bit different. It's a responsibility for Carderock and the Navy. We get into this all the time that if there's areas and programs that we don't have funding for to support, it doesn't matter. We still have to maintain the technical expertise. That's the hard part. It's market driven. There is no chunk of congressional money that comes in the budget that goes, here's Carderock, hire 3,000 people and let them go do hydro or go do signatures or do machinery. It's what work needs to be done. And but at the same time, Carderock has to maintain expertise in all the areas it's responsible for. So hydromechanics, ship control, propulsors, cost estimation, survivability, shock, underwater signatures and silencing, electric power, propulsion. So if for some reason the Navy's happy and goes, hey, we're just going to keep using the same propulsor designs, same with the Penn State, that doesn't mean that Carderock and Penn State get to say, well, we're just going to lay off all of our propulsor design people, because 10 years down the line when they say we need a new propulsor, Carderock and Penn State have to respond to that. It's not market driven. They have to maintain expertise. It's a responsibility of the organizations. Products and service, this is one of the major things I think that Carderock tries to focus on in general, is linking the technical community to the war fighters. We do get to talk to the sailors, we get to talk to the boat captains, we get to see the boats, we get to go out on them. We develop, integrate, and maintain warfighting systems, evaluate solutions, enable smart buyer decisions. It's getting tougher. What you do with the dollars now to get what the systems and the capability the Navy needs, that's tighter and tighter. It's going to get really hard in the next 3 months. We'll see what the new budget comes out looking like. Verify ships and ship weapon systems are safe and effective, life cycle support, technical linkage to the Coast Guard, and it's all these things. It is one of the things you have to remember, that it's the things that the industry can't do, won't do, or shouldn't do. There's a lot of things that they shouldn't be doing because of classification and security issues. If industry can do it, certainly industry is doing it right now. Science and technology, design requirements, acquisition, construction, fleet simulation, and service testing and evaluation. One of the things that is different these days, and we'll get into, and I'll mention it now, and I think Tim might get into it, it's changing. The world's changing, the budget's changing, the Navy's changing. We're talking about all of a sudden, or not even all of a sudden, we're talking about 50-year ships. A 50-year ship is an unknown animal. How do you design a 50-year ship? How do you design something that's going to be used 50 years from now in the world that exists 50 years from now? I went back and looked at this. 50 years ago, there were no LEDs. LEDs were invented in 62 or 63 in that time frame. So you're just getting LEDs. There was no cell phones. There was no GPS. GPS was 73 is when the idea came out. 77 is when they got some of the satellites up. So you're going to talk about implementing infrastructure on a ship and be able to install technology, and you're going to want to be able to do that over the entire lifetime of the ship, and you're going to have to do it for things that don't even exist right now. You can't even think of them right now. I mean, we went through the whole evolution even on just building infrastructure, where we're talking about, hey, the internet's coming up, it's, the 90s, and every single building they built had cable laid for internet, and you're going, that's stupid, because 10 years later you're doing wireless and you don't have to lay infrastructure down. There's a giant cost of that. So you're going to be doing stuff on ships where you're going to say, oh no, we can be smart on a 50-year ship, we can be modular, we can make all these interfaces, and you're going to be laying cable and coming up with connectors that basically within the lifetime of that 50 years, they're going to come, and the technology is going to come, be implemented, and disappear within the lifetime of that hull form. How is that really going to work? That's a whole new design cycle. The other thing that's driving it is what is the real cost of a ship like that? What is the total cost of a platform? It's everything. It's not just getting it in the water. It's training, it's maintenance, it's the entire cost of the ship over its lifetime. So Carderock's focused on all those things. It's everywhere around the U.S. for the most part. So what we're really talking about is West Bethesda, where I'm at, and Philadelphia, where Tim's at. which is the Ship Systems Engineering Station in Philly. But Carderock has sites all over. Bayview, Idaho, where they test the large-scale submarine vehicle. Ketchikan, where there's up in Alaska, where the acoustic range, Puget Sound, near the sub base in Bangor, the LCC in Memphis, which is large cavitation channel, and then South Florida range, which is the East Coast acoustic range, and STAFAC, and Canaveral, and then the small boat detachment combatant craft in Norfolk. So Carderock's spread around. It's actually over 3,300 people now. It's almost 34, 35-ish now. 1.4 billion. 65% of them are science and engineers. 35% are other. Don't ask me what other is. That's just it could be anything at this point. Contract people. But it is a highly science and engineering structured business. There's Carderock again. You can see the Potomac River to the south. It was here for a reason. It was built after the World War II. The Potomac. It was the source of water for the tow tanks back then. This is overall structure. This is the one that nobody. I don't really care about it. The commander's up here, or the captain, technical director, and there's basically 5 technical codes. There's some other codes in here, code 10, code 30 on support pieces, but you're really looking at 5 technical codes: ship systems integration and design, which is the systems integration and naval architecture design part of the Carderock and the Navy. Hydromechanics, the department I'm in, it is the testing of hull forms, testing of and design of propulsors, operating envelopes for submarines, some support to the aircraft and naval aviation. Survivability, structures, and materials is exactly that. It is structures, it is materials, it is the combining both of them. They do body armor design. They do a lot of materials coatings for other reasons other than structures or survivability, but really low friction coatings, anti biological growth kind of coatings are all in there. Signatures is everything related to signatures, both acoustic and non-acoustic. And machinery research and engineering department up in Philadelphia, Code 90, which Tim was going to talk about. So the hydromechanics department, this is it. This is what Carderock started out doing way back when Admiral Taylor built the little experimental water basin down at the Navy Yard, and then they came out and built the longer tanks out at Carderock. You can see the tank. It's 50 feet across. It's 20 feet deep. The carriage is here. That model is probably a 20-foot model. It goes up and down the basin. 20 knots is the highest speed. Most of the stuff is done probably in 5 or 6. Maneuvering seakeeping basin was built in the 60s. It is basically a football field with mostly 21-foot depth and a trench that's 30 feet deep. Submarine maneuvering and all the seakeeping testing is going on there. And then there's a rotating arm to do steady turns. And then there's a bunch of other facilities. That's just a sample. Ship signatures. They both do acoustic and magnetic. They do all signatures, so both magnetic, acoustic, and radar signatures. They can do model testing for submarines and ships at their magnetic field lab, so you can see them put these little models in these chambers and measure the magnetic fields around it for the magnetic structures, anechoic flow for noise, and they've got a whole wide range of, they take, once again, all the departments pretty much hire all ranges of engineers and scientists. Structures, survivability, materials, code 60, they build these structures, they crush them, they blow them up, they do material research, the whole bit. Metallic and non-metallic, a lot of composite work being done. Ships and systems engineering is really Tim's thing, which I'll let him talk about. Everything inside the hull is what it's talked about. So this is what, going back, this is what the Navy is, this is what we do. This isn't what I do. What I do is, on the research side, I do fluids. It is what I wanted to do. I like fluids. I like breaking waves. I like, it doesn't make any sense. I grew up in Indiana, but what I wanted to, the fluids part did, but the breaking waves. But that's why I headed out to San Diego. But it is all about sort of staying fixated on what you want to, what you're interested in, and letting your career go from that. It is something that it's really easy for me to come to work. I get to support 300 people in the hydromechanics department of what they want to do. I get to work for the Navy and do something that it's easy. It's stuff that matters. I've been on ships. I've seen the stuff I've worked on. Beyond ships that exist today, you get to work on the new designs. It's a little bit different. You're going to come into the Navy now, and if you work on, Ohio replacement, or you work on a cruiser and it's a 50-year ship, I don't know what you're going to start your career working on a ship, and you're going to retire from your career, and that ship is the ship you first put out in the water is still going to be there. Maybe that's a good thing. It is cool though. I don't think we ever get over the fact that you get to drive down past Norfolk or San Diego or Bangor and see ships and submarines that you've been on, ships and submarines that the stuff you've worked on is on. And you realize that it does matter. And when you realize that you see the ships you've been on out in the world doing what they're supposed to be doing, you kind of go, okay, this is a job that matters. So it makes it easy. At the same time, you get to do a lot of other things. I get to go around and do research. I get to still teach at Maryland, so it's kind of everything you wanted. So I'm going to let Tim talk about Code 90, and then we're going to go through internships, and then we'll take some questions. Let me see if I can.
Tom or the folks in West Bethesda called and said they wanted me to come and present. I wasn't quite sure what the audience and the intent was. So what I'm going to try to do is not duplicate anything that Tom said. And in fact, in the middle of my presentation, because I tried to change some things at the last minute, what I'm going to do is I'm going to stop and just kind of verbally tell you how I ended up, kind of where I am today. Not necessarily this evening, but where I am today. I told a couple folks on the way in that funny thing is I went to school here at Penn State, and the last time I was in this room was 29 years ago taking a Geography 102 course. So it was Urban Geography, I think. I don't know if they still have that, but so Tom talked to you a little bit about the entire organization, and what I want to do is kind of tell you a little bit about what's going on in Philadelphia. And what Philadelphia has is it covers the entire spectrum, and Tom mentioned it, the cradle to grave portion for the machinery components. So if you think of West Bethesda as having everything to do with the ship hull and the propulsors, so you have all the hydrodynamics and the acoustics of the hull, and those portions of the ship are in West Bethesda. In Philadelphia, it's all the machinery systems. So all the guts of the ship and kind of the things that make the screws turn. We don't do any of the weapon systems and things like that. Those are other warfare centers. So what we have in Philadelphia is the full spectrum for machinery systems. So we do all the machinery research and development, and also all the in-service engineering, which means that all the equipment on board the ships that are sailing the oceans today are also maintained. All the engineering for upgrades is done in Philadelphia for those pieces of machinery. So it's a little different